Do a quick review of 3.1, which is graphing two linear equations in two variables. And I want to move my camera over here just a little bit, got a shadow there. The steps for graphing is 1, you're going to develop a table. 2, choose the scale. Label your axes, X and Y. Plot your points. Draw the line, connect those points basically, and then label your line. For this example, I'm going to use 3.1e, which is found on page 96. It says graph y equals negative x minus 3. Well, the first thing I want to do is I want to develop a table. Now, most people do a table, and they do x, y, and they have their x, y's over here. I like to do my tables like this. X, and then I like to put in the center the equation. And then on the end, I like to put my y. I think of this as a computer. Whatever I'm inputting for x, I'm inputting into the computer for x. Computer's doing its thing, and then it gives me the output for y. And so I like to do that. And you're going to pick, usually it's always best to at least try 0. So I'm going to plug in 0. So basically I'm substituting 0 in for x. So I get y equals a minus 0 minus 3, which is a negative 3. So my input was 0, my output was a negative 3. And I do my math along here. A lot of people like to do their math off to the side, and they just, once they've done their math off to the side, they'll put 0 minus 3. So the book does a table like this. I like to do my tables like that. Then pick 2 more convenient points. Usually you only need 2 points to connect, to draw a line, but they recommend you do at least 3 or 4, and that you try to choose some negative and positive numbers on either side. So I'm going to try 2. So here I'm going to plug in 2 for x. A negative 2 minus 3, which is like a negative 2 plus a negative 3, gives me a negative 5. In other words, I moved to the left 2, moved to the left 3 more. I ended up at a negative 5 on my scale. So that is my output y. And then I try a negative number. I'm going to try negative 2. So y equals, now remember, there's already a minus sign right here, a negative sign, minus sign, however you want to count it. And then it's x. Well, x is a negative 2, so I'm going to put that in parentheses so that you can see what's going on here is now you're saying the opposite of a negative 2, or you can say a negative times a negative is positive. So this now becomes a positive 2, and 2 minus 3 is a negative 1. So again, my output is 1. So the coordinates I have is 2, negative 5, negative 2, negative 1. Those are the coordinates that I have. The second thing that it says to do is choose the scale. Well, I'm going to look. The highest positive number I have is 5 on the x-axis. And on the y-axis, the farthest away from 0, the absolute value, is 5. And so this is a higher absolute value. I'm going to make my scale up to 5. So now I'm going to also label my axis on my Cartesian plane. So you're going to use graph paper for this. All right. And here I have the y-axis. And here I have the x-axis. So I've labeled my x-axis, and now I'm ready to plot my points, right? But before I plot my points, remember we chose the scale. The scale was 5. So if you can label this 1, 2, 3, 4, 5. So I've gone 5 out that way. Negative 1, negative 2, negative 3, negative 4, negative 5. Going down, this is 1, 2, 3, 4, 5. And they're negatives, right? I'm just going to put negative out to the side because didn't do that. And then this is positive 1, 2, 3, 4, 5. Okay. I don't like leaving that. Since I'm doing this as an example for you, I'm going to erase and do it accurately. All right. So this is a negative 1, negative 2, negative 3, negative 4, negative 5. And now I'm ready to plot my points. Well, you remember what our points were, right? Y'all remember what our points were? Okay, so our points were, let's see if we can get it up here in the screen. I'm not sure if I can. Okay, we have 0, negative 3 is the first one. So I want to label 0, negative 3. So I want to plot that point. So I'm going to start at 0 on the x-axis because this represents the x. The y is 3. That means I'm going to go down 3. And there's my first point. The next one is 2, negative 5. So on the x-axis, I'm going to go to the positive 2 direction. And on the y-axis, I'm going to go down 5. So 2, 1, 2, 3, 4, 5. There's my second point. And then I have negative 2 on the x-axis, so negative is going to the left. I'm going to go 1, 2 to the left, and then down 1. So 1, 2, and then down 1. And so there are my 3 points that I have graphed. Now normally you wouldn't make your points that big, but I'm using a marker, so it's a little more challenging. I would use a pen. But here we go, and then you're going to draw a line. It says draw a line. And then label the line. So this is where you're going to need a straight edge. You're going to take a straight edge and make sure you're going through, get it lined up on your points, and you're going to draw a line, put arrows, because what that means is that your line is continuing on out to infinity, and then you're going to label the line by using your original equation. Remember, our original equation was y equals a negative x minus 3. So I'm going to put y equals a negative x minus 3. This is the label for this line. So these 3 points actually are solutions. But if you realize this, every point on this line is also a solution. So all the points on the line are a solution. So let's just check that out of curiosity. Let's look and see if we can find a nice even point. Here, if I come over 3 and down, this is 6. So this point right here is 3, 6. So I'm going to plug in 3 and 6 just to show you, and this is not what you have to do in graphing, but just to show you that any point on this line is going to give me a true statement, right? So I'm going to take the equation, I'm just going to write it up here. Y equals a negative x minus 3. I'm going to substitute 3 in for x. Oh, that should be negative 6, by the way, because I went down. So that's over 3, down 6. So that should be negative 6. And then y equals a negative 3 and a negative 3 is a negative 6. So I did get 3, negative 6. When I plugged in 3, I did end up with a negative 6, so that point worked. I could try other points as well on the line. And then real quickly, I just want to add, you've got a couple of problems that they throw in, so that are just slightly different at the end, that they're using some formulas. So let me just find one that might be easy, because they're wanting you to graph. It says the perimeter of an equilateral triangle equals 3 times the length of the side. Okay, so this is number 21 on page 97. So it's talking about the perimeter of a triangle. Okay, remember the perimeter of a triangle is you're measuring the outside, so you're adding each side. And when it says it's an equilateral triangle, what it's saying is that all the sides are equal, this particular type of triangle. So that would be, if this was if this side was S, the length S, then this one would be the length of S, and this would be the length of S. So basically, I'd get S plus S plus S. But a quicker way, instead of writing S plus S plus S, is just writing 3S. So the perimeter is 3S. I'll make that smaller so you know it's an S. All right? So there's a formula that the perimeter equals 3S. And then it asks you to write the formula for each rule and then graph the formula. All right, so we're going to graph the formula to find out what the solutions are that work. So you're still going to do the table. Only this time, remember we had y equals blah, 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 x, right? Remember? Well, in this case, the x is represented by s, and the y is represented by p. So think of this as your x's and your y's. And then here is your formula that you wrote out. So when s is 0, then p is 0. When s is 1, then p is 3. Let's always try negative. When it's a negative 1, then we get p equals 3 times a negative 1, which equals a negative 3. So here are your coordinates, 0, 0, 1, 3, negative 1, negative 3. And then you're going to go ahead and graph that. I'm just going to graph it real quick. Just kind of instead of using the, just because I decided to add this on last minute, I'm not going to use my graph paper. So I've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, because I chose my scale. All right. And so I'm going to plot my points. 0, 0, well, that's the origin, right? Then we have 1, 3. That means we're going to go over 1 and up 3. So that's going to be about right here. And then we had negative 1, negative 3, negative 1, negative 3. So there's my third point. And then it says graph. Remember, what you're going to do is you're going to connect your points, right? And then you're going to label your line. Your line is your P equals 3S was your equation. So just because they give you a formula and they're using different variables, don't let that throw you off. You just need to remember that. Remember we talked about dependent and independent. So P is dependent on S. S is the independent. So X is always the independent and Y is the dependent. X, so we have to do, this is the subject, okay? Remember we talked about that. Hopefully that helps you.